All right, this will be a video lesson for section 13.3. Again, we're only going to do these examples, so you'll need a sheet of paper. This probably looks familiar. I'd expect your answers to this one looking pretty similar to the previous one. So we'll only have 1, 2, 3, 4, 5 problems. This first one over here is not going to be a problem. It's going to be like a study to figure out why this formula works. Why does this exist? And how is it related to what we've been doing? So I'm going to go ahead and do a little demonstration again here. And we're going to find out how this sphere, which has the same height and the same radius/diameter as this cylinder, we're going to find out how these are related, just like we did with the cone in the previous one. So what I'll do is we'll fill up, this has a hole in the top, we're going to fill this up with water. Got it? So this is now full of water, and we're going to pour it into this one. All right. And we should see that it's about 2/3 of the way full. Now let's prove that it's 2/3 of the way full. What we learned last lesson is that a cone, it took 3 of these to fill this up. So this is about the same thing as 2 cones. So let's see if we do one more cone, if it fills it up right to the top. So here we go. Perfect. Perfectly full, right to the brim. So one cone and one sphere makes one of the cylinders. So this sphere is also twice what this cone is. We can maybe try and do that. Let's try and fill this sphere using this cone, and we'll just use it 2 times. So let's see. I don't know if I'll be able to aim very well. Kind of. Spilled a little bit. So there's one. It should be about half. It is about perfect. And we'll do it one more time. Here we go. That's not full. That's about full. I want a little extra full because I'm planning on spilling a little bit probably. There we go. Definitely spilled more than last time. Let's see how it looks though. Almost perfect. I did spill a little bit more than the first time, but this is the same thing as 2 cones. There is a little bubble in there. So we're going to take our cone formula and we're going to just double it because 2 cones makes a sphere. All right, I'll just throw all those in there and get rid of these as I spill water all over my computer. All right, let's see. So I'm going to talk about this in a couple ways because I literally just made up the 2 cones description just now. So we learned in the last lesson that volume of a cylinder, that's a cylinder, is pi r squared times the height divided by 3. Well, all we need to do on this is we need to double it. So it'll be 2 pi r squared height. And this diagram here, what this picture is showing us is the height of a sphere is the same thing as the radius plus another radius. So we have radius and radius. If we put those together, that's 2r. So the height is 2r. So we're going to replace this h with 2r. So the volume of a sphere, pretend that's a sphere. I don't really know how to symbolize a sphere. Volume of a sphere is going to be 2 pi r squared. And instead of h, it's going to be 2r divided by 3. Now we can simplify this. We can combine some like terms here in this expression here. The 2 and the 2 we can put together. 2 times 2 makes 4. So volume equals 4. Pi we can't combine anything with. But we have r to the 2nd power, and this is r to the 1st power. So this is going to be 4 pi r to the 3rd power divided by 3. And that is where our formula came from. Notice our formula said 4/3 pi r cubed, but I want to do it like this because I know that your calculator order of operations might mess up. So we're going to do the numerator, and then we're going to just divide by 3 in the end. So let's start with this first example down here on the bottom. We have a sphere that has a radius of 2.1 centimeters. So we'll start with the formula. I'll just use this one. Volume equals, so 4 times pi times, we need the radius to the third power now, because we're going radius times radius times radius in 3 dimensions. So the radius is 2.1, 2.1 times 2.1 times 2.1. We've got 3 of them, and we will need to divide by 3. So, calculator, 4 times pi times 2.1 times 2.1 times 2.1. We get 116 point blah, 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 blah. And we'll take that, divide by 3, and we get volume equals 38.8 centimeters to the third power for this one. So we should have this work written on our paper. If you draw that picture of that sphere, that'd be good too. Nice to have a model of a diagram of what we're doing. The next one up here is the 7 centimeter diameter sphere. So what we need to do first is we got to figure out what the radius is. So 7 divided by 2, that'll be 3.5. This is a 3.5 radius over here. 2 of those makes 7, but we don't want the diameter in our formula. We want the r, we want the radius. So we'll write our formula. Volume equals 4 pi r cubed divided by 3, and we'll plug all our numbers in. I'll do it below it. Volume equals 4 times pi times 3.5 times 3.5 times 3.5 divided by 3. Now, 4 times pi times 3.5. A lot of our calculators have this symbol here, this little arrow up. What that's going to do is it's going to be an exponent. So instead of typing 3.5 3 times, what I'll do is I'll just hit that little exponent button and I'll hit a 3. So now I have 3.5 to the third power, and I'll hit enter. It's not enter, that's the on button. Hit enter, we get 538.7. And remember, last step, we got to divide by 3. So we get volume equals 179.6 centimeters cubed. So that sphere could hold almost 180 of these things in it. Next one, a sphere has a radius of 10 centimeters. Well, let's write it out. Volume equals, I don't know if I really gave myself enough room to write the formula for all these, so I'll just write all the numbers. 4 times pi times, 10 times 10 times 10 is 1,000. So I'll just write 1,000 divided by 3. So volume equals 4,000 times pi divided by 3. I have 4,188.8 centimeters cubed. The next one, I'm going to try and squeeze it underneath these words. We've got a diameter of 3.4. So our radius of, what's 3.4 divided by 2? 1.7. So volume equals 4 pi times 1.7 times 1.7 times 1.7 divided by 3. So 4 times pi times 1.7 times 1.7 times 1.7 divided by 3. We get 20.6 meters cubed. For the last one, we have a person named Val, and she's measuring the diameter of a ball that's 12 inches. Well, that means the radius is 6 inches. How many cubic inches of air does this ball hold? Volume equals 4 pi r cubed over 3. 4 pi times 6 times 6 times 6 over 3. 4 times pi times 216 is what 6 to the third power is. I have that one memorized. It's one from our chart we made the other day, maybe like a month ago. 6 to the third power is 216. That's where I got this. 6 times 6 times 6 is 216. So 4 times pi times 216 equals 2714.336053. We got to divide that by 3. So we get volume equals 904.8 inches cubed. So that's how we do spheres. Very similar to how we do the other two. Cylinders, cones, and spheres are very related. So hopefully these formulas make sense to you. If they do not, you should probably send me an email or a comment and let me know, hey, this is super hard. I don't know how to do it. But the only things you need to know for a sphere is the radius and the formula. Okay? These are in your book. This formula, if you lose it, it's on page 412. It's in this video. We're done with geometry after this section. We're going to move into statistics starting next week. So you'll have 2 assignments, one for cones and cylinders, one for spheres, and that'll be all for the week.